Hello, everyone. Thank you for joining. I know this is a late hour, so I try to keep it energizing, interesting. So the last talk for today will be a great one. And today we will be talking about developing CLIs with Node, and specifically we will discuss the new capabilities that was added to Node recently. It makes this process a little bit great or better than before. So let's start. My name is Adir. I'm working at Wix. For the last year, I'm developing developer tools, and my team is responsible specifically for CLIs. So I have some experience in CLIs, and let's dive right in. So this is a very short list of some CLIs that you might know and use, from small and simple commands like cd and rm to much bigger and full-blown applications like git, npm, next, node, and so on. This is, you all know and I hope love some of them. But when some of you think about CLIs, this is sometimes what you experience or see, stuff that are not really pretty, that are not very convenient, and practically not things that you want to use as developers. And we need to ask the questions, do CLIs have to be ugly? Because let's be honest, it is hard to develop pretty CLIs. The built-in utilities are not great. For example, we can only use a very limited set of colors. We cannot control the font, not the type or the size. We cannot use images. We have very basic animations. We have very basic limited user input capabilities. For example, we can only use text. Users cannot use mouse or touch when they interact with CLIs. And even with the stuff that we can do, it is still pretty hard to develop pretty CLIs. But is this impossible? So no, it is definitely possible. And this is a great example of a pretty CLI. This is a create application flow. It has a really nice wizard. You can see the error state. We solve the error, we get to the next step. This is colorful, you can see nice UI, radio buttons, checkboxes. Again, colorful, nice, sleek, and this is all in the terminal, yeah? You can see some animations, a nice spinner. So practically, we can create great CLIs, and in this talk, I will try to show you how to do that. So let's continue. Here we can see a short list of guidelines for how to create CLI. As an industry, we've established some UX guidelines, let's say, for how to make good CLIs, and this is a very short list. But if you guys are interested in this topic, so I really encourage you to open this URL, clig.dev, G for guidelines. This is a super long and great resource for CLI best practices and tips and practical code examples that you can see and then take home and develop great CLIs by following those patterns. But now enough about talking, let's see some code. So during the next few slides, I will be showing a CLI that is essentially a DALI CLI. I give it a prompt, it goes to OpenAI API, go to DALI, generated some image, and show me back the image. This is like the generative AI period, so let's go with this example, a simple DALI CLI. Great, let's see the CLI. This is again the command. It consists of practically three parts. The first one is usually called the command. The second part is usually called the options. Those are the parts that start usually with one dash or two dashes. In this example is the size option. And we also have the last part, which is usually called the positional arguments. So now that we have the terminology, let's see how we can access those arguments in our code. So this is the most basic way to do it. Usually Node provides us with process.argv, and this is the output that we get. And this is, again, not very useful. First of all, the two arguments we usually don't care about. We only care about the rest. It is essentially the program and the file that were executed. Most CLIs don't really care, and they just slice the first two and get the rest. But the rest, it is still just an array. We cannot really connect between the stuff. We cannot understand what is the size and what is the positional argument, for example. So we need to kind of structure it and make it usable in the code. And thanks to a very recent Node addition, we have this built in. The util module in Node recently added the parseArgs function, which, as you can see in the following snippets, it gets a configuration of the options. Here I have a size option. It is of type string and also have a default value. And then I get it back structured. I have the positionals and the values. The positionals is an array with one item, which is the prompt, and the values consist of, again, one option, which is the size, and this is its value. So this is pretty easy to use, and it was not possible to do that easily in previous Node versions, but we did have some third-party libraries that did it for us. So if you use an older version of Node, or if you prefer some higher-level API, you still can obviously use third-party libraries, and those are the popular ones. So now let's continue. We know how to get the data from the command, but sometimes we want to make some validations. In this case, the DALI model only accepts a certain set of sizes. We cannot give it any size that we want. We can only give those 3 sizes. So we need to have some basic code to make validations. Here we check the size and the prompt, pretty basic, but this is a super basic CLI, and this code is not very scalable because regular CLI can have tens of different options, and we don't really want to have tens of ifs like that. And usually what a lot of people do is using some external library, for example, Zod, to make the verifications a little bit easier. In this case, I can define a schema. This is the argument that I expect to receive. I then parse the user data against this schema, or in other words, validate that it fits my schema. If it works, that's great. If it doesn't work, we will throw an exception, and the user will go and fix the errors. So this is, again, we're using Z, just one example. We have a lot of different libraries. This is, again, the popular ones. Now let's continue and talk about interactivity. Again, many CLIs, they don't really want you to fill all the data at execution time. You can also pass data at runtime. And this is one example. Here I allow the user to give me the size at runtime, and I show him this kind of an input. Let's say users can fill the data, click enter, and this is what they get. And this is add some interactivity to the CLI because we don't really want everything at execution time. And the code to do that is really simple. This is built-in Node.js capabilities, essentially 2 lines of code. I'm creating a read line interface. I'm running rl.question. The program will wait for the user to enter the text, and when the user hits enter, I will get the text on the next line. So this is super easy, thanks to Node.js and the relatively new promise-based API for read line. Now, sometimes we want more complicated UI or more advanced UI. In this example, we have sort of a drop-down or radio buttons, where from the beginning, we only allow the user to give us valid sizes. So this is what we can do. This is an interactive UI. The user can move between the different options, and when they settle on the option, they hit enter, they fill it, and we get it in the program. And the code for this is super simple as well. We just import the select function, we call it, give it the message, the different choices, and we await for the user response. The user fills the data, hit enter, we get it, we can proceed, super easy. And again, this is just the one example. We have a lot of other libraries. This is the popular ones. So if you want, you can use them. Let's talk about the last point in this section, and this is single executable applications. You might know that when you distribute CLIs built with Node to users, you essentially distribute the JavaScript files. And then users need to have Node.js installed on their machine in order to run your files, which is fine, but there is a problem with that. And the problem is that when you develop a CLI with Node, you need to know, or at least communicate to your users, which Node version you expect them to use, because you cannot use newer Node capabilities if the user will run your application in an older Node version, right? It will not be compatible. And in other, let's say, programming languages, for example, if you develop your CLIs with Rust or Go, you don't have this constraint, right? Because you just distribute a binary, the user run it, and no problem. So recently, Node.js have added support for that as well. And this is a new built-in module. It is called, not module, is basically a capability. It is called Node C, C for single executable applications, and I will show a demo of it in a minute. But this is super new and super beneficial. And again, we have a lot of, or some external solutions that do it as well. Now, before I jump into the code, let's look at this package.json file. This is an NPM package, and the only thing that I need to do in order to define it or to declare it as a CLI application is to have this bin field. And this is the only field that is needed. The key is essentially the command that we will give the user to use. So users, once they install this package, will be able to execute the DALI command. And the value is the script that will be executed. So this is that simple. By only adding this line of code, we make our package a CLI. And now let's see some code. I will move to VS Code here. I hope this is big enough. Now, this is again the entry point for that CLI. Let's run DALI again just to make sure we all understand how it works. This is the command. I will have one more zoom. This is the command. I run it. I have this nice spinner which spins until it finishes. It takes like 5 seconds. It's done. I can click that link, and I will have the generated image. So it works with DALI. Everything is fine. I can get it as a URL, and I also have a target option, which we will see in a second. And by that, I tell DALI to save the file directly in my directory. So let's see. It takes 5 seconds, generate the image. I get it here. It was added to here. I can click it and see the image. So this is the basic CLI. And now let's see how it works. So this is the entry point. Here we have this comment. This is called shebang. Essentially, it tells the shell to use Node in order to execute the following code. So this is the shebang, and I'm importing my file. So let's open this. Here we can see that I'm using pass args, like we've just seen. Let's close this one. This is the function. We give it the configuration of the options. We have the size option, which is a string, and the target option, which is also a string. We extract the size and the target and the position as argument. We will only have one argument, which will be the prompt. So we call another function now. This is a DALI function, and we give it the prompt, the size, and the target. Now, let's see the DALI command. I will not go over it one by line. I will just walk over the important stuff. This is the loader that will be shown at first and then replaced with the success message. We then convert the target from one set of values to another. So we get from the user a value which is either a URL or file, and we convert it to something else that in a second we will send to the OpenAI API. So URL stays URL and file becomes B64JSON. And then we send everything to OpenAI. This is the OpenAI SDK. We'll see it in a second. We call the createImage method, and we give it the prompt, the size, and the format. Again, URL or base64. And then we get back the image from OpenAI, and this is the SDK. We initialize it here, nothing special about it. Now let's continue with the program. So we called it this, we get back an image, and if it was a file, we save it to the file system and update the loader. If it wasn't a file, then it was a URL. So we should only show a different success message. And if something fails, so we failed the loader and exit the program with the failure. So this is the CLI. It is pretty basic, nothing special about it. And this is a real CLI. It works. If I will publish it, users can use it, and you can essentially see how easy it is to create CLIs with Node. This is just some JavaScript, nothing special. So this is the CLI, but I do want to focus on two different things. One is the testing, and the other is about I actually make it a binary and not a JavaScript file. So let's first talk about the testing part. I will close this to have some space, and those are the tests for my CLI. At Wix, we build a lot of CLIs, and we test all of them. We test a lot, so we test CLIs as well. They are no different. And here I also use, by the way, the built-in Node test runner. No jest, Mocha, anything, just not the test. First, let's run the tests and see how they look like. So I will run npm t. T is for test. This is a shortcut. You can see that, again, I simply run node --test and the pattern of the tests. And this is the output. It was pretty quick. I have 3 passing tests, and let's look at them. So this is a simple describe block. Before each test, I essentially start a server that mimics the OpenAI server. So when my CLI will try to go to the OpenAI server and get an image, this fake server will reply to it. I start it for each text, and let's look at the first test. So here we generate an image with a URL target. So this is a fake image URL. We configure the test kit that whenever it gets a request with this payload to respond with this response. And then we are actually running the CLI. I will repeat it again. We are actually running the CLI. We execute the DALI command. So let's open it and see how it works. This is a real end-to-end test. I do not mock anything. This is my real binary running as if user run it. So we have the execute CLI command. It gets the arguments from the test. And for each execution, it creates a new directory. It then resolves the path to the DALI binary. I will not go over it, but if you want, this is the code here below. And then I get the path for the binary, and I'm executing the binary with the given arguments in the newly created directory. So each test is running in a new directory. It is isolated, and data and state does not leak between tests. And this is a complete end-to-end test that, again, actually executing my CLI. So let's get back to the test. We execute the CLI. We give it the argument for this specific test. This test was for a URL target. So this is the URL target. And then we, again, just read the output of the process. So we read the output of the CLI, and we make sure that it has the success message of the file target, of the URL target, sorry, that it has the URL in the output, and the exit code was successful. 0 is a successful exit code for processes. So this is the first test. This is, again, a real end-to-end test. We can be very confident about the application because we run it just as a user. The next test is very similar. It only tests it with a file target. Let's see how it works. We have a fake base64 image. This is encoded. Then we configure the test kit as we did previously. This time, the response format is a bit different because this is an image. This is the response. We execute the CLI again. We are giving it the file target. And this is pretty similar to before. We are checking the output. And this is something that we didn't have before because now we save the file to the folder. So we want our test to be real end-to-end, we say. So we actually extract the path of the file from the output. We then go and read that file, and we make sure that the content of the saved file is equals to the content that we return from the server. So this is, again, end-to-end, and it covers everything. I can be sure that if my test pass, my CLI works as expected. It cannot fail. So this is test, and this is a really nice way to test CLIs, real end-to-end, super confident. And now I promise that I will show you how I create actual binaries for my CLI. So let's open the terminal again. Let's clear it. And now instead of running DALI, let's run DALI binary. Just to see that it works, and I will show how it was implemented. It will take a few seconds again. I can click the view image link, and I get an image, so it works, but let's see how it works. So previously we said that in order to register commands for the user, we need to add the bin field to package.json. So here we have the regular DALI command, which we already saw, and this is the new one, DALI binary. So this is how I add this command, but let's see what it does. Here we are pointing to a file which is in dist DALI. Let's open it. This is the dist folder. This is the DALI file. If I will click open anyway, you can see, let me scroll to the top. This is a binary file, right? This is not a JavaScript file. Let me just close those ones. Wrong button. Cool. This is a binary file, and you can see some spoilers here, Node C, we will see it in a second, but this is a binary file. And if I will search for my application code, you can see that it has my application code inside it. So this is a binary file with my code inside the binary. And let's see how it works. I will want to go over it too much because this is almost a copy-paste from the documentation, but we'll just understand how it works. So first, we need to transpile our application from ESM to CGS, because at least currently, Node C does not support ESM, so we have to use CGS. Then we prepare some configuration for C, not super important. We then run Node with cconfig, give it a config, and then we copy the Node binary, wrong button, copy the wrong binary to this directory. We remove a signature, not important, and then we inject into the binary file the blob which contains the application code. So this is essentially what injects my application code to the binary, and this is a real binary. I can give it to any of you, and you can run it regardless of what Node version that you have installed. And the Node version that he has right now is the one that I copied. So if you will have a CI pipeline, you can essentially generate binaries with the selected Node version that you want. Let's say the latest Node version. You can distribute it, and you are no longer depends on the user's installed Node version. So this is for this demo, and let's continue. This was the DALI CLI, a short example that essentially shows how using modern Node.js capabilities, we can create great CLIs. And now let's see something else. I'm not sure how many of you are front-end developers, but if you are, you will be happy to hear about this. You can write CLI applications using React. I know it sounds a bit what, but you can write CLI applications using React, using Ink. Ink essentially is like React Native, but for the terminal. It takes a React component and renders it to the terminal. Let's see a simple code. This is a React code. It might look like a web React code at the beginning, but you can see on the second line, we import something from a package called Ink. We import the render function and a text component. And then we take the JSX, this is also a JSX file, we take it and we render it. We have a spinner and the loading text, and if we will run this code in Node.js, we will get this output. This is again a React code that we render using Node.js, and this is what we get in the terminal. This is not a browser, this is the terminal. Let's see another example. This is a bit more complicated component. You can see that I can also use React state because this is just React, nothing special about it. This is a React component. I can use state. You can also see that I can apply some margins. I can actually use sort of CSS in my CLI application. And if I will render it, this is what you get. Again, React, CSS in my terminal. This is the output. And for the last example, this is an object, some data. I'm passing it to a table component. Those are all, by the way, third-party libraries, Ink table in this case. The previous was another Ink open source libraries. And if I will render it, I will get a nice table. Almost zero code in my application. I'm simply using some React component, which gives me a table layout. I give it data, and I get this nice output. Really easy. And Ink might sound weird, but actually a lot of very popular companies and CLIs are using it, from GitHub Copilot for CLI to our very own Wix CLI, which my teams at Wix develops, to a lot others, Cloudflare CLI, Gatsby CLI, Prisma CLI, Terraform, Bit, Blitz, and a lot more. So this is a super popular approach, and a lot of developer and teams actually really love it. And the last thing that I want to show you guys is Pastel. So if Ink was a nice addition, Pastel is kind of mind-blowing, because Pastel is essentially like Next.js for the CLI. We have almost zero configuration and zero boilerplate CLIs using Pastel, and it all works with React. And let's see another demo now. This one. Let me clear. This is a simple to-do application. Let's see how it works. I can run to-do list. I don't have any task right now. I can add a task. I can list the tasks again, and now I have one task. I can mark tasks as complete. This is the auto-generated ID, so I can pass it. And if I will list it again, I will see it styled differently. And I can also remove tasks. Right? No, if I will list it again, it is empty again. So this is a to-do CLI. This is a CLI application, and it is written with Pastel. So let's see how it looks like. Let's close the terminal to save some space and open the files. This is the main entry point of the application. We import Pastel. We initialize it. The only thing that we give it is import meta, and it will use it in order to traverse this folder and search for the commands folder. We'll open it in a second, and then we run the application. That's the entire configuration of my application. I don't have any other configuration, no boilerplate, this is all. And now for the business logic. So we saw previously that I have the to-do app command, to-do list command. All of those are simply files. I have a file per each command. Let's see the list command first. The list command doesn't receive any argument or option. It just returns some output. So this is a React component. This file expected to return a default function. So this is a component. It has some state. This is a TSX file, right? So this is JSX, React. We then have a use effect, which will be invoked when the component mounts, which is, in this case, when the command is being executed. So this is how we run code when the command starts. And here we simply load the to-dos from the database. We set them in the state. And then we have JSX that shows the data like we do on the web, right? So if there are no tasks, we show this test. And if there are tasks, so we can use, again, CSS. I'm using flex direction. I can have some paddings. This is JSX. Again, nothing special because this is just JSX. This is React. You don't need to learn anything new to do that. So this is the list command. Pretty simple. I don't have a lot to say, which is great. Now let's see a more complicated command. This is the add command. The add command, in addition to returning the JSX, it also gets some arguments, right? The task title. So this is how we define the argument of the command. We simply export the args const. We tell it which argument we expect. In this case, a single string argument. And this is the description. We have a single option, the verbose option. It is a Boolean and it defaults to false. And this is the description. And now, if I will write to do add and, for example, see the help menu. So first of all, I got it out of the box. I didn't implement any help menu. And all the text here, the task title, description, the default, they all come out of the box from Pastel and from those ZOD definitions. So this is super simple. Let's look at the implementation. We have the add component. It gets the first arguments. This is the to-do title. When the component mounts, it adds the to-do to the database. And then if it was verbose, so it shows some text. And if not, it just exits. And this is everything. Pastel, super easy to create CLIs. And that's everything from me. Thank you guys. I hope you enjoyed.